Good morning. Today we're going to build a SmallKat. We're going to start with the instructions on Hackaday.io, and we're going to finish out this video by finishing the electronics. Alright, let's dive right in. So the first thing you're going to want to do is go to the SmallKat website on our Hackaday.io page. Now, the first section you're going to want to pay attention to is the instructions section. So right over here, everybody see this? Go. Click on instructions. Instructions. There you go. And view all 9 instructions. Now I got all this stuff step by step that you should be doing. For the step where we assemble the electronics, we're also going to be using the cat build instructions.pdf. We're just going to open that up in a new tab. Cool. So, to begin with, you want to fork your SmallKat. Now, the way the SmallKat architecture works is that you have a few files that define your SmallKat. It's going to call other files that define all SmallKats, and ultimately will run inside Bowler Studio using the Bowler Studio built-in kinematic system. So, the first thing to do is go to Operation SmallKat /GrayCat, linked right here, and log in with your GitHub account and fork it. I've got it open over here, and I'm going to hit the fork button. Forking. Cool. Alright. Now, the next thing it has you do is copy the URL of your Git repo into the 2 files that in the repository you just forked. So, what that really means is go to this green clone or download button, click on it, make sure you're using the HTTPS version right there. And we're going to copy that URL by clicking this button or highlighting it and doing a Control-C. Cool. Now, the 2 places you need to edit it are files in the repo right here. So we're going to click on the first one, which is mediumcat.xml. I'm going to add it. And then anywhere you see GrayCat, you know you're going to have to replace it with your GrayCat. Paste it right there. Cool. And then the launch.groovy, edit, GrayCat, paste, whoopsie, I erased the quote. There we go. Great. Alright. Now back to our instructions. So we're going to launch our new our new copy of GrayCat in Bowler Studio. Let's go ahead and open up Bowler Studio. Logging in, doing its thing. Now we're going to open the repository that we just made. We go to the GitHub menu. Here, let me zoom in on the menus for you. We go to our GitHub menu. We're going to go to my repositories. We see Manifestus Demo and the GrayCat that we just created. I'm going to add it to my workspace and open from the workspace by highlighting the workspace menu. Click on Files. Hover over Files and click on Launch.groovy. We should see my name there. Great. And when I run it, we get our very own copy of the GreyCat. Now, the reason we made a copy is so that we can configure our particular GreyCat, all the configurations for our particular servos and how they're all set up. Here, let me switch it back to full menu. There you go. And you can see our configured GreyCat opening up on the window here. Now, if you want to see the CAD, just click on the CAD button. And if you want to see your GreyCat walk, you hit this little plus button here, press and hold, and your GreyCat should start walking. There you go. To make him turn, you use the rotate about Z. Good. Walk backwards, turn the other way. Great. Now we can see that our copy of the configuration loads up a cat. And in fact, if we wanted to, we can even check out the physics simulation by clicking on physics simulation and hitting run. Now when we make our cat walk, it'll walk inside a JBullet physics simulation. And turn, and turn the other way, and walk backwards. Cool. To reset our CAD, we uncheck the checkbox for Auto Generate CAD, and check it again. That'll load up our simulated model. Cool. Alright, so now we have a SmallKat. And the code that runs it is our code, as well as the configuration is our robot configuration. So you can see this is the one that belongs to me, with my name here. And you can see that we're running it by calling it here. Cool. Now, let's go back to our instructions and see what else we have to do. So we've just done step 1 and step 2. Now, step 3. Print all the STLs. Cool. Done. I prepped this step ahead of time because that takes a while. It takes about 2 print beds on a Lulzbot Taz 6. And so each one runs for about 20 hours. So about 40 hours of printing. Alright, next up, the ESP32 firmware. So, I'm going to switch over and show you ESP32. This is the ESP32 dev module that we're going to be using inside SmallKat. The ESP32 is plugged into a robot interface board, just like that. And we're going to plug in the USB cable to program it. Note that this LED comes on to indicate that there's power, and this one indicates that the 5-volt rail on the rib is powered. Put that there. Alright, so switch it back to the web browser. Now you see we're going to want to fork the firmware that goes onto our ESP32. So we click on this link here. And just like the control code, we're going to fork ESP32 servo server. Cool. Now, to program the ESP32, I'm assuming you have your Eclipse with the Slober plugin installed and the ESP32 toolchain set up. If you don't have those things, go set that up first. We have other instructions for that. We're going to assume your tool chains are set up for the moment. So we're going to click clone our GitHub URL and switch over to Eclipse. From here, we pop over to our GitHub menu by doing Window, Show View, Other, Git, Repositories, Open. Move it over here, make it a little bit more useful. Great. Then we're going to click on this little button here with the little green arrow, which is the clone button. Since I already copied the URL onto my clipboard, Eclipse knows that it's there and pre-populates all this information for me. Great. Next up, we're going to clone our ESP32 servo server. And hit finish. Great. We now have our forked version of the ESP32 servo server cloned. We're going to open it up in Eclipse. New. Create Arduino sketch. Next. We're not going to use the default location. We want to use the code that we've already cloned. Git ESP32 servo demo. Okay. And we want to make the project name match the INO that's inside. So we're just going to take off that little demo there. Next, use the ESP32 toolchain. If you don't see ESP32 here, you need to set up your toolchain. Make this a little bit bigger. Select the ESP32 dev module. CPU frequency, 240 megahertz. Core debug level, none. Flash frequency, 80. Flash mode, QIO. Flash size, 4. Partition scheme, SPIFs, default, 4 meg. PSRAM, disabled. And the upload speed, 921600. Now we hit next and finish. Sure. Let's take a look at the ESP32 slower perspective. Now we're going to set our serial port properties. Arduino. And select TTY USB 0 if you're on Linux. If you're on Mac or Windows, you'll have different options here. COM something on Windows and USB.TTY USB something, I don't know, on Mac. It is possible to get both working, but right now we're going to be doing all of our testing on Linux. Apply and close. Cool. Now we should be able to program our handy dandy ESP32 servo server. Do right click, index rebuild to get rid of our errors that aren't actually errors. Wait for the indexer to finish. And depending on how fast your computer is, this will go faster or slower for you. Cool. Now, we should be able to compile and program our ESP32 servo server. Now, I always say always, because Eclipse is smart enough to do partial compiles, and I never want to accidentally program something without compiling the changes I just made. This will take a few seconds to program. Almost done programming. Cool. Now we're going to pop over to the serial monitor, disable the scroll lock, and open up USB 0 at 115200. Note that the faster baud rate is used for programming, and this is the speed for printing, 115200. Okie dokie. It's printing a lot of something. Let's go ahead and turn that off. Save. And program it again. Alright, now the ESP32 is trying to connect to the Wi-Fi. It doesn't have a username or password yet, but it did scan the networks to see what's available. So we're going to go ahead and connect to Hephaestus 2, and you just copy from wherever it is and paste it into this little text area. Make sure that you have no line endings, that you have that set to none, and go ahead and send it. Now it's going to wait for the password. I set a special password so I can type it all in front of you. You're welcome to try this if you ever see my network, but I'll have changed it back. Alright, once it connects to the Wi-Fi network, you should get an IP address, and the robot is ready to connect in Bowler Studio. So now we're going to pop back over to Bowler Studio. We're going to disconnect our robot. Clear it out of the 3D window and close the control panel. Now, when we search for our robot, we should see a print statement in here saying it got a successful name check for the robot and a failed name check for the game controller, seeing as this is our robot, not our game controller. So, let's see if it works. Go ahead and hit run on your launch.groovy. Oopsie, I closed it. That was not what I meant to do. We will reopen Bowler Studio. And right before I accidentally closed it, it had in fact connected. And let's try this again. So, I'm going to reset the ESP32, which you can see printing down here. And it's going to connect to Hephaestus 2. There you go, nice and connected. And I'm going to run my new launch.groovy. Run. There you go. Success name, HID device. That's the name of the robot controller. So now, Bowler Studio, instead of being connected to a simulated robot, is now connected to your real, actual robot. Cool. I'll switch back to CAD mode. Alright. So what you can see here is your ESP32 is now connected to Bowler Studio and is running the code. As the robot walks, we'll see the servos moving in real life. But since there's no servos hooked up yet, we can't see it. Alright, thank you for watching.